Okay, so I'm assuming I'm having some issues here, so let's fix that. And now I'm assuming the stream is working, but I will double check. I had a pretty good day so far. The stream seems to be working. I fixed the visuals. Perfect. Hey everyone, welcome to Coffee with Chloe in the afternoon. Chloe Lewis here, co-founder of the Marmaj Foundation, lead of the Marmaj Research DAO, and I am currently undergoing a 4-month fellowship with the Ethereum protocol. So if I go into, I guess, research, and then you go into the Ethereum Protocol Fellowship, you'll see that I have some updates publicly on the Doulos 819 GitHub account for like the weekly updates, for example. And so I have week 0 from last week here. I have my Obsidian open, and I'm actually going to update this. I want to be more specific. So week 0 was the intro, in my opinion. And then we're going to create a new, not a new folder. Let's delete that. We are going, create a new note called week 1, and we're going to call it project, I can call it like a survey. And there you go. So I'll by the end of the program in 4 months, I'll have multiple of these weekly updates. So for week 1, I kind of had, project setup and learning was kind of like my intro. Like, what's my project going to be about? What am I going to be learning about? And kind of getting my head around what the project I wanted to do. So I wanted to better understand implementing practical cryptography in systems. So I was going through this textbook from 2010 called Cryptography Engineering, and the goal was to set up a study group in the next couple of weeks. The idea was to be able to support a team to implement protocol specs in Rust by the end, in the future. So, for example, implementing Waku v2 or some, Waku v2 specs in Rust would be awesome in the future. And so there's kind of like this 0 to production in Rust book for building like web servers in Rust that I kind of wanted to go through as well, just to kind of give me hands-on experience building a production-ready system in Rust just for fun. And then by the end of this program, some teams that I would love to work on just to help in whatever way possible would be teams like Status, trying to do like messaging and validation, or running nodes on resource constraint devices. VAC PDP, working on private secure messaging in general. In like a peer-to-peer ecosystem, obviously VAC-P2P, and then Portal Network, working on light client implementations for Ethereum specifically. All 3 teams I think are doing really cool work in the space. So my plans for the 4 months are to work with Thor as my mentor as I work to implement cryptography widgets in Rust. That's like a specific use case where I want whatever kind of project that I build to actually not just be like a written paper or written support of some sort, but also actually be something built in Rust. I'm not sure if I'll get there by the end of the 4 months. So much to learn. Every time I dig into a new part of cryptography, a new part of implementing something, I feel as though, what's it called? There's so much more to learn around the corner, but I feel like I'm getting to a point after last week and into this week and that's why I want to do a survey this week, is because I really feel like I'm starting to find out what some of the problems might be and the way that they're currently being solved in an educational standpoint, in a pedagogy standpoint. Anyways, the study groups will be starting soon, and I've been trying to curate some sort of reading list. The reading list is here as well. It's quite random right now, and I have like a really long reading list. So actually in the weekly updates at the end of week 0, I have like a long And this actually led to some really good resources, which I'll go through soon. So we can go back to Obsidian, because I might make some notes. So pre-fellowship was spent like choosing a mentor, Thor, who I'll be working with, and starting to go through the reading list materials, gathering resources. I've been trying to focus on some personal goals, trying not to burn out. So I'm trying to stick to only doing 20 hours a week. Usually this is difficult for me. I usually get started around 8 a.m., just starting to with videos or reading. And then I kind of usually end up doing a bit after 5 as well. I do take some breaks in between for meetings, for like marmaj projects and stuff. But I'm trying to stick to 20 hours a week and trying not to do stuff on weekends. Usually I'll work late Friday or work, Sunday night, but still, or not really work. I'm studying research, I guess. So open office hours and study groups as much as possible, learning in the community. A lot. So like one of the best groups I found for this is actually one of the groups I went to today, which I'll kind of note when I get into the week 1 survey in a bit. Where are we? Yeah. And then lots of brushing up on Rust and number theory. So yeah, the pre-fellowship was a lot of this. This intro week, you'll see a lot less number theory, also a lot less Rust. I really started digging into like Obsidian, digging into the textbooks, holding office hours, and started setting notes up for the Zero to Production book, which I do need to keep going through Tuesdays and Thursdays, at least for like maybe half an hour, even if I can just get on here and start streaming through Zero to Prod. Wednesday, I went through some crypto engineering notes. I'm actually going to be changing the textbook for this probably to a textbook from Dan Bonnet, written in 2020, so 10 years newer, which is awesome. Met with Thor. Realized study groups start in 2 weeks. And yeah, there's just been like, what's this one?
Hey everybody, this is Gregory from DAF University. So I'm so excited to be on.
Is this the wrong? Oh no. Okay, sorry, it's the right video. I don't know what happened there. So this is the correct video from ZK Porter. That's actually been great for learning in a community, and they have a Discord group they've opened up. What happened? Zero knowledge proofs in practice.
Hey everybody, this is Gregory from DAF University. So I'm so excited to be on Free Code Camp today to teach you how to become a blockchain developer. I'm going to take you over the shoulder and teach you how to write Ethereum smart contracts with a Solidity programming language.
Sorry, okay, I have the wrong note here. Thursday. Okay, this is why. It's from ZK Porter here.
On YouTube,
that
and so
annoying and bad. See, this is kind of why I like having it all here. So let's change out this video, and then when I update this on GitHub, it'll update there as well. Started to attend the Ethereum Fellowship calls again. I do have to get that back on my just normal calendar, which is quite a bit to add to the calendar, but I really miss going to these calls. There's also the EIP 4844 implementers call. I need to go watch through these calls this week as well. I feel behind, but my main project does not have to do with EIP 4844 specifically. I am focusing more on what I'm going to be showing soon, what's in the background here. So playing around with Rust-based crypto libraries was really fun, which is from the crypto engineering textbook. And then Friday, I streamed quite a bit, organized a lot of exercises till chapter 3, and then I kind of realized that I kind of want to work on this like textbook-like resource. Okay, so that was what I did last week. So first things first, as we start out, let's get a title. Whoops. Let's get a title. Open a new tab. Let's get a title for week 1. Survey. Oops. of current. So I'm going to start doing it like this now, where at the start of each week, I'm going to open up the new note for the weekly update. And then I'm just going to do a quick like what happened last week. So, last week, decided I want to come up with like actual decisions that happened that you things that actually happened or like what concluded. So decided I wanted the EPF, or let's be really specific, my EPF project to be Okay, so last week I decided on general EPF project theme. And then like this week, I want to survey of current cryptography. Applied cryptography, ZK, and when I say resources, like decided on general EPF project theme. Educational resources to support the learning pathway of perspective. Okay. And so cryptography engineer, in my opinion, is quite a high term. The literal term for cryptography engineer is probably someone who actually builds cryptographic systems, not necessarily someone who builds applications that use cryptography. And I guess I mean a bit of both. I would like this to be the type of resource here is the idea that the profile of the type of user of this resource would hopefully be someone who wants to not only understand how to use cryptography, but also why certain parts of cryptography are used and put together. And also someone, who wants to find most of what they need in one place. So there's lots of ideas. Yeah, this is just a survey this week, though. So this is just ideas I'm having for now. Survey of current applied cryptography ZK resources to aid in applying cryptography in Rust. Yeah, let's keep it even this. That's kind of high level. I'm not even, actually, you know what, specific, I wouldn't be focusing on that this week. This week, I'm just trying to find what's useful, what's helpful. I found some really good blog posts and links of things that might help someone in order. So let's get there. Okay, so that's kind of week is one and what's going on. Last time we kind of had like intro, goals, plans, and this is kind of like stuff for the entire 4 months because I kind of wanted to have like overview overall. This time I plan to have more of like a paragraph into like what a survey of the current resources means, and then kind of start breaking up my week. So there are I'll try and be very vague for now and just high level, and then I'll try and edit this later. So there are and like see, I don't want to be too like vague. Let's be vague. Okay. There are also great courses available. There are also thorough courses available to support So while these resources exist, it can take more time that is available or reasonable for many that are interested to through them all, or to know which ones to, or to know which ones Okay, so this is kind of like the problem statement, or like how I see things currently. So maybe I'll try and write it like this. Like this is kind of the, how do you, oh gosh, am I gonna, no, no, oh my gosh, no, how do you bold something again? Am I actually forgetting how to bold in, oh my gosh, how to bold in Markdown? I'm so tired. Yeah, I wanted to do this one, but anyways, double asterisk it is. Problem. I don't know why I didn't do it like that. There are many publicly available resources that are efficient at explaining how current and historical systems work. There are also thorough courses available to support structured learning to teach core cryptography concepts. While these resources exist, it could take more time than available or reasonable for interested cryptography engineers to go through. It's not really interested cryptography engineers. It's for engineers learning how to apply cryptography. For engineers. It can take more time than is available for engineers interested in learning to apply cryptography to go through them all. Okay, not written very well, but it's written. And then, you know, propose. All right, potential solution, because I'm not even sure, you know, if this is the right direction yet, but I like it for now as like, how do I help for now while I gain the skill set or knowledge to be able to actually like support Ethereum more deeply and create a resource that combines any already available resources. Oh gosh, I can't spell. Resources, examples that should I probably with students that learners can interact with and so this is kind of a bigger idea, I guess, but there's two resources that kind of shape my ideas, I guess. So, and they're like high level, and they're not really the perfect resource yet, but these are the resources that like kind of solidify my idea. So, I do want to try and get like some basic example up. And Bonnet. Is that how you spell Dan Bonnet? Bone H. Bonnet. So there's the ZK whiteboard sessions. But it's not just that. It's along with the textbook, which is in my week 0. Whoops, I didn't mean to open this. I have week 0 right here. So week 0, there's a book. Let's open the book first. Might keep things simple. A graduate course in applied cryptography by Dan Bonet and Victor Shoup. So for me, there's the like these two things together. Let's take out Dan Bonet actually and put it right here. So for this, you have like one part, which is the text, right? Which is available right here. And it's written by these two people them. I think I put too many spaces here. Okay. And then I'll write about them later. But then you have the Z-code whiteboard sessions, which in my opinion is just a specific, with other things too. A graduate course in applied cryptography. Oh yeah, there's multiple things here. There's one which is like text based. Let's see if this works. This might not work. We have text based, and then you have video. Oops. You have video, text, video, and then you have, oops, hybrid. So my opinion, you know, if you go, let's go back to video. Or how do you share the whole playlist? There you go. Copy. Whoops. There you go. And let's just say, if you want like a pure like overview of applying cryptography, you can go through like the Zero Knowledge Whiteboard series. Specifically, if you want a hybrid video, there's a new one coming, but Coursera Cryptography 1. I think this is the right course. It seems to be very similar. Is this the right course? It's literally just Coursera Learn Crypto. Oh my gosh. I tried to look through it. It seems to be very similar to the textbook, although it doesn't go through as much. So like this, for example, goes through 7 weeks, and it stops at, you know, public key encryption. Actually, that's kind of short. There's a longer one. This textbook, for example, goes through, okay, block ciphers, chosen plain text, message integrity, so authentication, okay, a lot of attacks, to be honest, authenticated, so yeah, authentication with encryption, public key cryptography. So the Coursera says it goes through some basics of, where are we? Public key encryption. Probably not nearly as, detailed as any of this. And then, attacks on the encryption, digital signatures, fast hash-based This text just seems so much more detailed than the text I was going through previously. Elliptic curve encryption and pairings, all kind of basic stuff. This isn't in the textbooks from previously, so I think this is the new stuff, like post-quantum cryptography. Definitely haven't gone through any lattice stuff for me. These are all like important curves. I haven't really gone through much. Analysis of number theory assumptions. It goes through number theory as well. Protocols for identification and login. So again, getting into like details that are actually useful for trying to do like login type stuff and like identification features for Sigma protocols. I need to go into that more. I don't know what the heck's going on there. But okay, so it goes into zero knowledge and way beyond that. But in my opinion, this Coursera course, seems to get you halfway through the textbook. And for the crypto engineering text, so right now we're at chapter 3, block ciphers. If you go through this text, it kind of stops at kind of like storing secrets and public key infrastructure, the clock, right? Implement issues you might get with implementation, introduction to cryptographic, so like full protocols like the transport layer. So where are we? The text here is kind of doing the same thing here with like specific curves that are used, going through specific like Lamport framework, winter knits, like going through all these Diffie-Hellman key exchange. So it just seems more updated with the type of things it's going through. And then this kind of just goes through, this seems helpful. This chapter here, regardless. See, this is why I kind of run through both textbooks in some ways. Like, okay, this all seems pretty simple. Hash functions seem pretty straightforward. MAC, secure channels, kind of the same things going to be talked about. Just in like different order. Stream ciphers. Okay. Oops. I did not mean to go that far. This is a long textbook. Wow. Yeah, I don't see as much in this graduate. I think they expect maybe that you know it already. Let's see. Digital signatures, encryption. Yeah, this is like specifically like fast hash base. Whereas this actually seems like a really good chapter for me to go through in general. Chapter 3. So generating random anyways, how to attack a random generator. Because this might be like a simpler way of doing it, but I'm more thinking about actually chapter 10. If it's a really good chapter on primes, I probably want to read it. So actually, I think I need a note somewhere just to be like a random note, like read chapter 10. So this is where I'll get down to like, sorry. And I'll just be like, Monday. And then I just want to be like, read chapter 10, C Engineering 2010. Chapter 10. Diffie-Hellman's pretty straightforward. RSA is pretty straightforward. And yeah, I probably just want to read through chapter 10 specifically. Chapter 19 looks really good too. Like, what is PKI in reality, and seeing, how it is actually now. No, but chapter 10, like to read, which I didn't do yet, and I'll keep it at the top so I remember. But what I did do today was I started off the day with episode 2. Whoops. Why do I feel like I went through part 3 today and not part 2? I'm having a hard time remembering. I'm trying to do this thing where I try and stream or try and update my notes in the evening instead of doing it all day long. But now the problem is that I forget things. Okay, so on Friday, I went through... Oh no, where is it? Did I not write them down? That's terrible. I didn't write them down. Maybe I skipped... No, I watched all of these. Why? Okay. Well, I'm just going to put it on for today then, because I'm getting confused. And I'm just going to put... Whoops. Anyways, let's copy the playlist link. So my goal is to keep it simpler. So actually, I could just copy this and do this. And then just be like, vid 2 and 3. Today I also went through... Where do I have that written? On week 0, day... Here. I don't like how it's written there, but... I'm gonna call it... ZK Porter, week 2, class 1. And there's like usually week 2 class 1 and week 2 class 2, or like and so this is actually incorrect. My back is kind of hurting for the video. Wait, where's the new video? Live? There it is. Number 3. Just so I can keep track. And so, whoops. Let's come here. Let's do this. Okay. Oh, shoot. No. Gosh, sorry. What I wanted to do was also be more general here. So ZK Porter playlist. It should show ZK class.
It's super great to just have so much excitement about this.
The full playlist. There we go. So I guess he didn't update the playlist yet. That's okay. I'm just gonna try my best to be like ZK Porter, which will link to the general playlist. And then I'm going to try at least to just be like, oh, here it is. Oh, one video is unavailable or hidden. So maybe he took off Introduction to ZKP and just took class 2 and 3. Whatever. Doesn't matter. The point is, I have links to those videos previously. Now I have links here. Now I can say like week 2, class 1. what is it called? Oh, just called Class 3. So maybe I'll just call it Class 3 Tornado Cash White Paper and just be like Class 3 Tornado Cash White Paper. And maybe I could even just like, if I'm being really specific, you know, I can even I'll link directly to the video just to be super difficult with people. There you go. What else? I'm kind of like doing multiple things. Hybrid was this like Coursera. Is that even how you spell Coursera? No. Coursera crypto. I'm not even sure how you like define that, whatever, but literally this seems like a really cool hybrid. There's PowerPoint, there's notes, there's class. It's not perfect, but it does kind of get you through this like intro like session. And maybe I'll just do like the flipperjacks intro, like what an intro would look like. Pre materials, and then it would be like I'm not gonna make a table. It takes too much work. I probably don't have very many. I'll just do text to video. Mostly text and video. And I have some like basic ones like MITCS. That's probably like one of the basics. There's Rust with Boggy. Rust with Boggy. There's, you know, algebra. These are a bit different. Like, okay, there's algebra. I'll just write them all out first. What do they call it? Discrete mathematics. There's like basic things you kind of like have. I do have like, let me see if I can go to my library and see if I can. Oh yeah, number theory. I don't have the best links for all of these, but I have like just general ones for now. Let's see. I have statistics, networking. Like binary tree stuff, but like you kind of just get into that as you go. Honestly, this is kind of pretty much what I have. Let's see. I feel like I'm missing one thing, but I don't know where it went, so I'm pretty confused. I guess I should just call it mathematical proofs. Or like where is maybe calculus too, but oh, vector. And I'll get there in a second too. This is just basics for now. I'll add to this list. Non-exhaustive. Maybe I should just write. Like, this is just like very basic pre-materials. Text. So, free video resources to for basic for like basic background. There's like a lot more like complex stuff, but that's definitely the basic. Free like articles, blogs for background. And there's like the text-based stuff is going to be so many of them, but like first principles. Explained from first principles, internet, from first principles. I'm just going to keep it simple. Number theory. Those are like probably my favorite articles I've ever read. They were just so in depth. The one on email was, I don't think I got through it. It's pretty good as well. But wasn't as, exhaustive. Why am I having such a hard time finding what I'm looking for? Did I not save it? Oh no. View all history? Am I going to find it in my history? Probably. I've gone through so many videos. But I'm just wondering why it's not saved. Yeah, there's so much stuff to go through. My gosh. Okay. There it is. Number full theory. Is it just not saved? Okay. So yeah, I got my number theory course here as well. And there's lots of other stuff. I can get the majority of these links right here, to be honest. I should be able to go to my library, and then hopefully it's pretty straight. Okay, I'll have to actually
the
click
same
it.
element in the original list. In other words, the two lists are both reduced residue systems, and so they must be the
So to me, again, these are all basics, and I'm kind of just going these to set up my week. And so I'll try and do this on Monday to set up my week. I'll try and show my Friday flow to submit all of this on Fridays. Mathematical proofs. There's a couple of videos for this one, actually. There's like a 1 and a 2. Whoops. So there's like a simpler... No, where's my... Not history. Not... Oh yeah, playlists. What's going on? What's going on? Why doesn't this one like me? It isn't showing my playlist. Okay, let's see if I can find the playlist if I do things normally. Well, who am I logged in under right now? Okay. Okay, here we go. I was like, where is the rest of my stuff? Oh, this one. This one's awesome, and this one.
This is mathematics for computer science.
This one, so this one had like 111 videos
that we have introduced, and we are going
That's awesome.
to write
this
logical
one, and they're like
for some English sentences.
5
so we're gonna
20 minutes
take
each.
some English sentences.
This one has 55-minute videos, around 5 to 10 minutes each. To me,
so far.
this is the first video, and whoops, Adam Panagos. So the first one's from Adam Panagos, and the second one is from like MIT OpenCourseware or whatever. Like MIT OpenCourseware. So let's see. I don't know why it's, yeah, don't give me such a weird link. Yeah, why did this give us a link? Okay, let's fix this one
In this
first.
problem, we're going to get a little
So,
practice working with some of the logical connectives that we have introduced, and we are going to write logical
Yeah,
expressions
let's fix this first.
for some English sentences. So we're going to
link here.
take some English sentences and convert them into
normal.
kind of mathematical equations using some of the things that we
And then
learned
for
so far.
the
For instance,
MIT link, they use this weird way to write it out. Instructors here too. So maybe I'll just put the instructor's name. Who cares? Get 2 different instructors. And then
In 6042, we're going to be pretty concerned with proofs.
MIT OCW. And then, whoops. Reopen, close tab.
In 6042, we're going to be pretty concerned with proofs. We're going to try to help you learn how to.
And now we should finally be there. Number theory, algebra. A lot of these are just like free code camp or really straightforward ones. Again, non-exhaustive list. Everybody who might happen upon this. Literally, it's just like, hopefully you do, you know, basics. If you can go through and understand the basic computer science course. So let's get that one. If you can go through and understand. I can't even remember where I put the computer science course. I don't know why it's not here. So weird to me. Why this is showing up like that. Oh, EDU, that's why. It's all under here. So, yeah. So like for me, this is like a full college algebra course. Again, very basics. But if you understand all of the algebra, you can probably go through some of the number theory. If you can get through, I have a lot of other stuff here that like I want to go through. I've gone through previously and I forget. Haven't gone through this full thing yet. Seems pretty good so far. I will finish it just for fun to make sure it's like all useful, but it seems like a really useful use of the time, 24 hours. I went through like 1.5x speed or like even a bit faster, I'm not sure. A lot of basic stuff in there to help you kind of on board. But if you understand that, you can probably understand Rust with Boggy. Where's my Rust with Boggy stuff? Whoops. Rust with Boggy. I don't know why. Am I gonna have to refine the Rust with Boggy stuff? Learn Rust. Probably the first thing that comes up these days. It's not the first thing that comes up these days. Oh my gosh. Yeah, let's get rusty. Playlists. Rustling book. Super basic. Super generic. Right? But if you... And there's a lot of other videos on this channel. I've watched all the Rustling book ones, and I've watched a few others as well. Great YouTube. And there's more. Like, you can't just only watch this and think, okay, wow, I have Rust in my, you know, down pat. But if you can go through the MIT... open courseware computer science, and then you can go through Rust with Boggy, go through some algebra. The algebra should get you through enough to go through mathematical proofs. The mathematical proofs should get you far enough to get into number theory. And let's also go into explain from first principles. Here's the blog. Here is the internet, and we can kind of just do this fun thing, and then we can go to number theory. There's a really good article I actually got from Vitalik, or not can get from Vitalik. Someone was sharing, it was like 2016, about like R1 rank 1 constraint systems and all that fun stuff. Seems like a great read. I haven't gone through it yet, so I won't really add it to the list yet. But once you've gone through these two articles, I feel like... So this was the rank 1 constraint system. I don't think this would be the next thing to go into by any means, but... copy message link. Copy link. Still think it would be up there somewhere. After going through number theory, you might want to learn more about kind of how to create snarks in this way. There are better, more efficient blog posts to go through before this. But there's like, you know, Thor. Okay, this won't work. I mean, yeah, this won't work. I have to go to this one. See if this works. Nope. There are some... Am I already logged in here, hopefully? Nope. Maybe I'll do that. Oh, gosh. Oh, indiscrete, discrete log. Indiscrete, discrete log. See? I can't spell, though. So that's my problem. Thor here, discrete log, and then like there's a few here. There's a lot here. But let's pick these two. So copy link, and let's say that, you know, the user knows about internet number theory. So now we go to 0, maybe like Thor, or just like let's call it. I already had it written like this somewhere else, but let's call it indiscrete discrete log. I don't know why you want to be so difficult about this. So yeah, I'm gonna keep this much simpler, of course, and just link this whole thing just to the site, and then, oh gosh, there we go. It's being difficult. Whoops. No. Okay. It's being so difficult. Maybe because the screen is small. Maybe it's just a visual bug. Yeah, it's just a visual issue. Okay, so indiscrete-discrete-log.com. I don't want it to say .com. I just want it to say indiscrete-discrete-log. And then I want to have the links to these. Copy. Wait. Man. Why make this so difficult? In my opinion. Why are you being so difficult? Oh, it's actually working. I just gotta remove that, and it should be perfect. Mwahaha. Okay, then I can take this one and put it right here, and then just, oops. There we go. So, the hope is that someone goes through these articles, goes through these two. I think you'd probably have quite the gap here still, to be honest, between going through indiscrete discrete log and then getting straight into like rank 1 constraint systems and all of that. But I'm sure there's quite a bit on Vitalik's blog, for example, that does share this. So, Vitalik.ca, and I'm not going to try and go through everything, different types, like there's just like, okay, you know what, is there a simple way of just like math, maybe? Blockchains, maybe? ZK, like there's just so many, right? Different types of ZKMs, some to use privacy. How trusted setups work. So let's just open a tab of a few. So how trusted setups work, and I have not read through all of these, I don't think. Okay, so, but the whole point is that I want to as well, and they're all here. So, some of this, I mean, all of this uses cryptography, but we need like more general. Ooh, this one looks fun. Why sharding is great. Let's check it out. Limits to blockchain scalability. I think I can't tell which is. The names of these aren't very descriptive. Encapsulated version of complexity. How does I already got? Yeah, I already got that one. Obviously, this could be useful. Yeah. Okay, So let's just say, and then where's the math ones? Vertical trees, interesting. Fast Fourier transformations, I can't remember. And yeah, we're just going to stay away from that. So if we just assume that we're going to keep it really simple, and we're going to go to Vitalik Buterin's website as someone who's educating on this stuff in text and keep it really simple. That would be vitalik.ca. And there's more to read different resources, but we're keeping this, again, these are background resources that, like, you might want to go through. And so in these resources, you would have, okay, so this is going through, oh gosh, necessary background, elliptic curves, fun. Elliptic curves and elliptic curve pairings. It's not even in this group. Ah, okay. There's just so much stuff, and let's just keep it, because it links to other things, which is great. So, how do trusted setups work? You need to already know about elliptic curves pairings. Talking about sharding, the scalability, trilemma. This is all right. Talking about commitments and stuff, and why it works, and yeah, like this seems like a more like general one. I want to keep it in general one. Limits to blockchains. Again, this is a more general one. That's good. Let's keep that up there. The limits. Then maybe why sharding. When was this one written? April. Let's do that. Why sharding, the limits, endgame. This again looks very similar about like why rollups and all that stuff, and data availability, centric rollup, MEV, proposer builder separation, ZK. Yeah, again, just like general information about how this works. 21 December. Using it for privacy. June, July, August. Vertical trees, just straight math and how they're coming in, and then fast Fourier transforms. So the math stuff is actually earlier. Okay, so let's do fast Fourier transforms. Vertical trees. Not like these are any real order anyways, but oops. And then we're going to go in order this way. So this is the website. Why sharding is great. I mean, in my opinion, if someone can go through all these articles, they're more than hopefully on the right way to understanding, like, at least for Ethereum specifically, what to do there. The limits to blockchain, and a lot of this stuff is general enough to where, besides Ethereum, if you're just hoping to figure out and understand, how we're going to scale the blockchain and all this stuff, hopefully this starts being clear. Yeah, I was doing them not one at a time, but now I feel like I want to, so it's a bit faster. How do trusted setups work? I should call it like Ethereum endgame, or like if endgame, like, you know, okay, like endgame, like so people know what the heck they might be reading or getting into. And I'm trying to keep these as, you know, the types of things for now at least that someone could get through in like a weekend, right? I think a lot of reading lists are just like endless resources that you could just never hope to get through. Not a weekend. This would take you at least a week. For sure. I mean, just the articles at the top would take you quite a while. Okay. Now we're talking about actually like using ZK snarks for privacy. You know, again, getting into... again, have not read all of these, but I have read some of these, or parts of these, or tweets about these, and so the different types of... And I think this is like the last type of one, where you're actually going into like, how is this being implemented on chain, and what are the differences? If people actually started to care about, you know, how this all works. Gotta start drinking my soup. Whoops. Okay. And the last one is Verkle trees, which is like a new data structure they might use for Ethereum. Okay, let's add Verkle to a dictionary. Okay. So we're going to chill on this for now. Okay. You can go away, actually. That's much better. Whoops. Okay, so this is kind of the just non-exhaustive pre-materials for text, non-exhaustive pre-materials for video. Again, I think these text materials are just like, I don't like text materials as much. They're great for kind of taking notes and understanding at a deeper level. The videos are great for overviews as well. So MIT OpenCourseware, just for getting a background in computer science, Rust with Boggy, for specifically understanding how Rust works, going through some basic algebra, and then understanding mathematical proofs. There's some things missing there in the math section specifically, so I'll probably split this up to like programming, math, and different like sections. After number theory, there's like specifically, oh, whoops. Yeah, there's specifically, where is it? Should be here. Let's go back to YouTube. And let's go to the libs. And, what are we looking for again? We're looking for, I don't think I have anything that fun in, because, you know, more Verkle trees things, and like you can watch a video on it instead of, you know, reading about it. Same kind of stuff. It's just what you learn from each one. Oh, I think I had a specific EDU video that I heard was good for cryptography specifically. Where do I put these things? I'm not very good at keeping track of my YouTube stuff, which I guess is why I'm using Obsidian now to keep track. It might be in watch later. I save things from my phone a lot, and so it'll just randomly get saved somewhere or nowhere or whatever. Calculus. Ooh, pairings in cryptography looks like a fun one. I do have to watch that one. Implementer's call. Let me put this a bit higher, actually, on the list. There was another... Oh, is this from...
that is organized by
Dan Bonet
Danny
again.
Weeks and
How long ago was
Vinod
this?
Viswanathan. Daniel's here, but where's Vinod?
2 years ago. Okay,
And
I'm gonna steal this one too.
all these
Just
talks are
because I like it. So, videos. And I'm just gonna be like, okay, the next video would be it might not actually be the next one. Oh, well, yeah. That's probably a great start for intro stuff. Okay. There's another thing I wanted to go through, but that's kind of going to a whole other course. Anyways. I don't know what I have open. So many things. The point is, though, is now we're here, going through week 1. We have, like, the, I'll even call it a potential problem, like, so I don't go too deep into it. Potential problem, potential solution. Here are some non-exhaustive pre-materials and text and video that might help someone get up to speed with kind of applied cryptography specifically in like a blockchain setting. And so one example specifically of like what I might want to come up with, is this kind of graduate course in applied cryptography plus ZK whiteboard sessions. Let's call it. There's another thing I want to find actually. It's a zkhack.dev. White position events. Maybe it's under events. No, it wasn't ZK hack. Man. It was like ZK. It wasn't ZK hack. It was zkhack.dev. This is not it as well. Why can't I find this? 0. Okay, it wouldn't be here, but the Zero Knowledge podcast, and they have a link tree, and maybe it's here. They have an intro to ZK series. Cute. Website. Okay, so. Oh, is this the actual. I think this is the actual, like. Oh, if you want to listen. Oh, this is cute. I'll keep this as like a. I think there's so much information. Okay, so I'll keep this as like a background, like like if someone's really just like audio, and then I can just be like, whoops, did not mean to do that. Zero ZKFM. Let's just keep it simple. There's so many, stuff here. I can be here all day, literally going through it. So in my opinion, specifically, there's example. Learn ZK. Oops. ZK. I mean, this thing goes through way more than zero knowledge, but it goes through all the backgrounds and stops at zero knowledge and goes through this. So, in my opinion, if you want to learn zero knowledge, there's this whole huge thing, not perfect, but you can go through these resources and have in my opinion, a pretty large grasp or understanding. The exercises in being conducted in Rust might help support here. So, wow, that was a lot of context behind what's happening, and I think we have a full resources here. Monday, trying to get through this. So to read, I want to get through this, and then technically started reading this here. So I think the main takeaways, the main takeaways is that I really enjoy the book. So it seems like an efficient upgrade to CE 2010. More important than notes would be answers for chapter exercises. And then I would still need notes for myself to answer. So even if I did let's go back to the textbook. Let's go to chapter 2 and go to the beginning. So again, a lot more complex, going through all the proofs of how things work. And it would take me a lot longer probably to go through everything here, but in my opinion, let's see if there's... Oh, sorry. Chapter 1 is just the intro. Chapter 2 actually goes through stuff. And here we go. So... okay, are these... I'm seeing all these questions here. Is there questions throughout the entire thing? I haven't gone through more than a bit of it, so. Oh, cool. It seems like there's questions. Oh, okay, so I'm confused. I'm yes, everything seems here. Okay, so here you go, 2.6 exercises. It seems like the goal for me, so for example, multiplicative one-time pad. We may also define a multiplication mod p, a variation of the one-time pad. This is a cipher, I think epsilon ed defined over KMC, where K is equal to M is equal to C, is in the set of 1 to prime minus 1, P minus 1, where P is a prime. Encryption and decryption are defined as follows. Encryption, takes the key in the message, and that's equal to K times the message mod P. For decryption, you take the key plus the ciphertext, plus the cipher, which equals the key inverse times the cipher mod P. Here, K to the negative 1 denotes the multiplicative inverse of K modulo P. Verify the correctness property for this cipher and prove that it is perfectly secure. So I think the problem for this is that it wants me to write a proof. Oh, everything here is proofs. Ugh. See, I feel like this is where I was talking about earlier, where both books are useful and I'm learning a lot from both books. But this book, the actual examples and definitions are very math-based, and there's proofs built in, and it seems very useful, and I'm learning a lot. Whereas in this book, they seem to leave the proofs for the appendix and for later, and focus a lot more on actually implementing instead of the math. And so I feel like I am going to have to go through both textbooks. And so potentially what I'll do is, so right now here, for example, I'm on like chapter 3.5. Going through, I went through AES already, went through Two Fish. I think I need to like go through these a bit quicker, just take notes quickly on these. These are all old algorithms anyway, so maybe just read through these and kind of skip over the notes potentially. And these exercises here seem a lot more like specific to like programming instead of the ones in the graduate book seem, from what I have not gone through this book yet, but this book seems like a lot more like you're dealing with proofs and verifying the cryptography. That concludes the proof. But I want to read through the proofs, understand them. But for the exercises, let's see. I haven't gone through other chapters here yet either. So let's potentially look at like chapter here. Yeah, this seems a lot more like actually going through the exercises in the Crypto Engineering 2010 book. So actually, I should write this down. So started reading. Seems like an efficient, not even upgrade. Pairing to CE 2010, valuable definitions, proofs, and math. Just math in general, like mathematical exercises. More important than notes would be actually not answers for the chapter exercises, and then not this. So, in my opinion, more important than taking notes would be like finding definitions or proofs to help understand larger ideas. So, in my opinion, again, the exercises here and the topics will help me understand what's happening at a higher level, and then hopefully with this textbook, reading through it, from what I've read through so far, which was not much. Pretty sure I've just read through the intro here, Shannon ciphers imperfect security. I've read through the first page here, and then reading through all these examples of one-time pads, and I was learning a lot just of just in general. I enjoy reading through a textbook, but I probably didn't even get past here yet, page 7. Maybe I read some of this. Oh yeah, I read. Okay, I stopped at page 8 so far. So I think some of these definitions and how they work and understanding them in my brain will be super helpful. But I don't think it'll be as helpful to go through all the examples and do the proofs. I'm not even that great with proofs yet, so maybe later on, but not right now. So that's how I'm feeling right now for all of this. Seems like an efficient pairing. More important than general notes would be ideas and understanding the text proofs. If I can understand everything in the textbook, I think I'm okay for this one. But for the crypto engineering one, I think I have to actually go through and do the exercises. So I think this leads me as well to maybe I should be a bit more specific. So just talk about this book in general, and then talk about how I, started reading through text, currently at page 8, so have not gone through that much of it at all. Okay, seems like an efficient pairing. More important than general notes would be this. To read, and then here again, I don't want to just be that generic. I want to talk about the book. So I think the way I do that these days is just going straight to GitHub. Oh shoot, I wanted to find the event. ZK Summit, there's jobs, blogs, all Rust stuff, of course. I'm looking for something specific and I just don't seem to be able to find it right now. Lots of fun stuff here. Wow. Cool. Anyways, not what I'm looking for. I found it in a tweet. I signed up for it, and I just cannot find, man, what I'm looking for. Okay. Currently, though, I am trying to go to GitHub. And I'm trying to just easily get, nope, not what I'm trying to do. Notes on books, copy link address. So when I talk about crypto engineering, 2010, this is what I'm talking about, the notes here. And to keep it simple, I want to, I'm just going to continue with the book, honestly. So, chapter like 9 or 10 or whatever specifically, that's fine. I didn't do much with the book today, and I probably won't do much with the book today, but the goal is to finish chapter 3 this week. Actually, I like to finish chapter, well, I'm talking about notes usually these days. I don't really care so much about what I read on my own. So I want to finish chapter 3 this week, and start doing exercises. you know, and like I kind of have a different where are we? Crypto engineering repo, which I'm hoping to have my examples in, but this is probably the part where I need the most like support or outside support. So that's a goal, though. It's a goal. Yeah, I'm not gonna touch too much on that yet. This is just a goal. I haven't done it yet. I did focus on this, ZK Porter, and these seem to be my main Monday, Wednesday, Friday tasks, focusing on cryptography and doing a survey. I feel like now that I have all this written out, it took me quite a while to kind of organize it all. I did have other things. So there was class 3 that I did. There was the ZK whiteboard sessions. I'll probably just end off today watching another video because the next one seemed very, very interesting, going through 2, 3, and 4. Yeah, so I can just go to it. So ZK whiteboard sessions. So yeah, number 3, or sorry. Oh wait, this isn't what I thought it was. Why? Sorry, maybe I'm confused. I thought... Oh wait.
Welcome back, everyone.
Perfect.
In this segment, we're going to finish our construction of the snark, and in particular, I want to show you all the beautiful algebraic...
I'm all over the place today. I think, actually, 2 and 3 is going to be today. So, I think I watched video 1 a couple days ago. Maybe. So maybe I'll just do 1, 2, and 3. Because I'll finish 3 today, and I think I did 1 and 2 like over the weekend or today. Or I know I finished 2 today. I think I did 1 like Sunday or Monday this morning early or something like that. Started so early it's hard to remember. Maybe like I'll just be like 1 weekend, and then 2 and 3, the ZK Porter. So this is generally what my Tuesday, Monday, Wednesday, Fridays are generally going to look like. Crypto engineering for sure. These things. I didn't go through any notes on the zero to production in Rust, sadly. And sadly didn't take any notes today. I have my tablet. I'm planning on taking notes on while I'm going through some of these streams. But yeah, I think today I'm just going to finish off the 3rd video because it seems like it's going through. It's kind of like the basics, like module 1, 2, and 3, and then it seems like it goes into like snark versus starks and all this other kind of crazy stuff. But yeah, I want to finish this 3rd one today. I don't know why it says I'm already done it. I don't think I... Oh yeah, we start with the IOP. Yeah, I'm just trying to make sure. Oh yes, it's going through what we did last time, then it kind of goes for... I don't know why it's saying I'm done with it. I'm definitely not done. I don't think. Okay, so I think this is good to go for now. So usually I would then come here, git add, git commit, just like set up week 1 update. You know, what else did we do? And input task complete for Monday. Then we shall just pushity. Awesome. And for this one I do, anyways, doesn't even matter. But yeah, hopefully that is all clear. Oh shoot, actually I will push it on up. So let's go to MJR. Let's push it onto main as well, and then delete master. Okay, delete branch. And then I don't know why MJR always acts like it doesn't have any. I have a README. It's very basic. Maybe like an about section. Oh, there you go. No description, nothing. Repo for the marmaj research. I guess DAO. Eventually, this repo could be managed by many people. But yeah. Yeah, sure. Save changes. And what else? Okay, so yeah, now we have. I gotta start getting these images into their own folder. Maybe I can do that easily. Let's see. Expand. Settings. Already complicated. File recovery. Ha! Daily notes. Template. Dang it. I need to make like a file anyways, right? So a new folder called images, right? And I want all these images to go in there. Oh, I can just do the command palette from right. Oh, that's not what I want. Template, file location, page preview. Nah, man, I need, yeah. Default view for new tabs. Yeah. Strict line breaks. Show formatter. Show line number. Maybe. I don't know if I like that, but I might like that. Don't want right to left. That sounds scary. Some spell checks, some auto pair brackets, auto pair markdown. Yes, please. Tab, advanced, Vim key bindings. Man. Thought I was gonna get something simple. Oh, files and links. You dumb. It's right here probably. Deleted files with a trash. Automatic update. Yes. What do you mean? Please do. Default location for new notes. Yeah. New link format. Shortest possible. Use wiki links instead of markdown. Yeah, that's fine, man. Oh, but then that won't work on. Man, does this mean? Okay, I'll have to check that one out. Subfolder images. Okay, so this should be auto saved. Okay, I see line numbers now. That's fine. I don't mind that. I'm gonna take these bad boys and drop them into images. I'm not even sure if everything will still work, but let's look at my notes. Okay, still works for now. Because it should auto do that. And then what other thing did I take out that I was like, nah, I forget my settings already. These links. Okay. So if I do that, I don't know, man. That's fine. Okay, so you have images, which I don't care about. We have research. Man, why'd I make images top level though? That was stupid. Maybe so images could be used by everything, no matter where they are. Sure, I'll keep it there. Okay, sure. This is good for now. I also want to go through some Coursera stuff. Maybe I'll go through some. You know what? It's late in the day. Maybe I'll just go through some. The Coursera was pretty cool. I'm not gonna lie. It was like super chill. I'm not even sure which Google account I'm using for this. I think I'm using Chloe the Dev. I don't know. But I decided I'm gonna try and see like what is. There's only one course available on Coursera. It seems pretty interesting. And it's really straightforward so far. I mean, again, very basic stuff. Got it. And so I went through like just discrete probability. Pretty helpful, pretty cool. So I'm going to try and go through the majority of the video information just to see what type of information is available for free and publicly to others. And that'll hopefully give me an overview of like, more concretely the potential solution to figure out like, or like what type of resources can I create, or how do I link these ideas closer together, and stuff like that. So like week 1 has quite a lot of stuff to it, I kind of skip like what is cryptography and history of cryptography. I will probably go through back through all of it. Sorry, I will not go through the readings, but I will go through for the next 7 weeks. Who's messaging me? I don't even know. I will go through these. So that is one thing. Oh, I kind of forgot that I was doing this. I'm just gonna. So I will add that to my like week 1. Just be like, this is the other thing I'm kind of doing as like a way to see what's available out there. I think I put it here, so let's do that. And then let's say, what goes in there? It's, Coursera Crypto Week 1, I guess, is like what's actually linked here. And then I already have like the Coursera crypto course in general linked. So going through it in general, and the idea is I'm going through week 1 today. I went through it a bit yesterday, but just to see what it was like. It seemed useful. Again, just to see what's available, and that's going to be it for today. So Tuesday, oh my gosh, not doing anything else today except for going through one more video, and that'll just be me here watching this video. So yeah, Dan Bonet doing their thing, 13 minutes, and I will be done. So I will end this stream. I will finish my coffee and my soup watching this for a bit, and then I'll end off my day. And then tomorrow is more of a like programming, like Rust and math day. So particularly, you know, if I want to be specific, I'm going to be going through either like number theory work specifically. Maybe I'll go through this patterns in cryptography video, or try and find other resources that I think would fit kind of this, you know, survey type of week that I'm going through. Next week, I hope to kind of get away from the survey and going more into application. So I guess getting ready for the study group, figuring out what types of exercises we could start with. And so to me, I think anything where we can start just getting people to set up or fork a library in Rust and start going through some, you know, examples would be wonderful. So tomorrow I plan to, Rust and math, and then I can even how did this work? Oh yeah, and then I could just git add, git commit, and just be like set up for Tuesday, right? And then git push, and then we're good kind of to go for tomorrow. So toodles all, it's been fun, and